2000, they started looking at ecosystem services and those benefits that are provided to the community through these different types of ecosystems. And I'm not going to quote the company that come up with this method, but what they're looking at is regulating versus supporting. So the benefits to the regulating, which is climate regulation, water quality, pest management, and then those supporting things that come from managing those ecosystems. So when we're looking at agriculture as an ecosystem in itself, there are those same benefits that are going in, as well as we've got food and fiber that are coming out of it. So what does that ecosystem mean to the producer? It means different things to different producers because it depends upon your system and the type of ecosystem that you're farming and how you're treating it. So here is a pretty good graphic of the different types of ecosystems, and everyone always says mimic native range, right? So over here on the right-hand side, this is looking at ecosystems on similar types of soils, but in 5 different ecosystems. And those provisions that are being provided are on those color charts. So you can see in the forest situation, we're sacrificing food production. We're not getting a lot of food off of the forest. We may be getting nuts and other things, but not a lot of food production. When we go down here to our conventional farming system, though, you can see the majority of that ecosystem is relatively food production based. We've lost a lot of the biological, the carbon sequestration, water quality, water supply, biodiversity, habitat, air quality, and disease mitigation are not in that conventional farm. So what we're trying to do is to get folks to look at more of those outside of the conventional farm system and look more towards, like you keep saying, native range, farm, mimic native range. And so then we get down to our ecological farm. So here we're provisioning a lot of food production, but we're also getting a lot of the benefits of that system that's underneath the rangeland and the forest. Forest is actually one of our better ecosystems when you're looking at the soil surface and what it can provide for soil. So this is another way of looking at that. So each of those axes on that flower graph there are those provisioning or providing functions of this soil system. So in the native natural ecosystem, you see crop production, and that flower petal is really, really low. But on the other aspects, it's rather large. Same thing again here, intensive cropland, we've maxed out on our crop production. Our other components of these ecosystems, though, the services that this ecosystem is providing is minimal at best. So here we go again, we say mimic native range, and we try to get those different components of that ecosystem to kind of flower out and be a bigger part of that whole system. And a lot of that, you're wondering how can that be done. So first off, we want to kind of consider the different services that are important to Kansas producers. And if you're just looking at producers as a whole in the conventional realm, not our agro-ecosystem farmers, I would call it Gale, and there's a few others across the state that look beyond some of this. But this is the majority of our regular row crop producers. Some of the other things, though, that can be provided in that ecosystem, though, are just management ease. Once you get to the point where you're farming in this type of system, there's a lot less management in trying to decide when you're going to apply fertilizers, when you're going to go in and spray, when you're going to go and scout fields. A lot of that can be quite a bit minimized when you're going to more of an advanced system. The wildlife conservation is usually skyrockets in these types of systems. The AMF, that's Brascular mycorrhizae fungi. That potential there just really ramps up once you get to more of a native or mimicking that ecosystem, that agro-ecosystem farm system. Also, there's the nitrate retention, and then the NOx reduction, and then phosphorus availability. That's a really big. One of the biggest components is that carbon, adding that carbon to the soil. That's pretty much the whole piece of the puzzle that makes everything fit together. So here we are back to this again. You're saying the 4 different principles of soil health. I'm putting it out here as how to reap the benefits of these systems is by planting the cover crops, using diversify your rotations. And that means just not corn, beans. It means adding in either cover crops to diversify your rotation or looking beyond that to a different cropping system altogether, which would be a corn, bean, and wheat. Working together with other producers in your area to find a buyer for different types of crops. A lot of that in the farm mentality is very autonomous. You're very on your own. You plant your stuff, you sell it. You don't work a lot in groups or coalitions to find these different markets. And if you could do that, and you could bring in different crops that could help with those diversifying. So what does planting cover crops do? It increases your chemical. There's four factors when building soil. There's chemical factors, biological, and physical. The chemical, what that does is it increases that nutrient exchange by planting cover crops. Under the biological factors, you can see we've added in a lot of our different soil critters, the mycorrhizae, the bacteria. We're getting that in more of a balance, and the columbulas and those chedagardes, the water bearers, all of those different types of soil critters feed off of each other and produce and then help with that chemical factor. And then the physical is pretty much obvious. That's that decreasing bulk density, increasing infiltration and available water. So when we're looking at cover crops, and he mentioned these different functional groups, this is one of them, and this is just some of the things that these different functional groups can provide. And if you go across the bottom, that's crimson clover, that's a pea, that's that medic. No, that's the chickling vetch, that's the pea, and then over here in the corner we have sun hemp. So those are some different species that provide those different services. Here we're looking at the broadleaf plants. You got your buckwheat there, phacelia, chicory, my favorite here, the safflower, you can see it's kind of wicked looking, the purple top turnip, and then we've got the daikon radish. Speaking of radish, I'll show you this little poster board. There at the PMC, we thought, well, they're selling all these radishes, right? And they've got a little different, we got 4 different varieties, and they all say one radish is better than the other radish. Well, we planted them all, and we thought, where were we going to see which one goes the deepest? Because the soil was all the same where there was that sandy loam. So we thought we're going to plant all these radishes in here and see which one goes the deepest. Because, the tillage radish is the radish you're supposed to have, because it's going to go the deepest. And so we planted all of them, and guess what? They all went the same depth, which was the length of, as far as we could get, was the length of the tailgate on the truck. Wow. So, yeah, just for illustration's sake, everyone knows how wide that is. But we did not get, the root is right here, it's about the size of a hair. It gets a little thicker pencil size, about halfway up that truck bed. And then we got this big tuber, you can see up towards the upper end there. But they all performed exactly the same. So we're doing it again this year, and now we put it closer to water so we can wash everything and get as much of the root as we possibly can because it broke off. And they all do perform differently under different soil types, and you'll see probably under clays, you'll see more of them sticking up out of the ground like you see here, as opposed to, in that sandy loam. But we had that hard pan at 6 inches, it hit it and it popped up and out. I don't know if he's got the one on here. Oh, here, 6 inches, see my root, whoop, turn. You can see right there that compaction layer, it turned. And then also we had found some worms in there, look at that worm. Look at that worm. You're following that root right down, that root line is right there in that space. So you can see there's a lot of benefits to all of these. I really like the biofumigation aspect of the radish and the turnips both, because that's an extra added component in pest management that a lot of people don't think about. They really stink when they rot. Pollinator species is just one more component. They're great flowering species, those broadleaf plants. Here we got our cool season grasses, and you can see what some of the things they do. One of their biggest, claims to fame, of course, is sequestering nitrogen, or scavenging it, pulling it up, utilizing it, keeping it from running off. Also, cereal rye and that I never say this right, allelopathic effect that it has, which is, a toxin that it produces, keeps other plants from growing around it. That's a good thing when you're looking at weed control. Sun hemp does the same thing. I tell you what, that stuff's crazy with the amount of toxin that it releases. 3 years in some of our plots, we still have weeds from that sun hemp residue. Of course, we had 8-foot tall sun hemp. I don't suggest you do that. You can't farm through it. It's horrible. Warm season grasses, you can see we've got the forage sorghum, and we've got a lot of the millets. There's the German millet, foxtail millet, pearl millet, the brown midrib corn. A lot of these, do these different things, but another thing they do that, is a real big component is forage. So when we're looking at diversifying your rotation, one thing that we, look at is planting different species to allow that diversity, and whether it's intercropping or just adding another, rotation into your current rotation. There's a lot of different things that you can see these do over time. Here's another good graph. This is just a comparison of a corn bean versus a corn bean oat and a corn bean oat 2-year alfalfa rotation. You can look at the yield here just from, it's not very significant for the corn versus the beans, but it is a little bit higher, in that 2006 to 2011, that's just 5 years. They got a little bit of a bump in yield, plus they got a different crop that they had to market, alfalfa hay. Here's another thing, energy output. This is the amount of energy that was used in order to put these crops in. You can see there's a significant decrease in the amount of energy being consumed by putting in this 4-year rotation. The reason why the bump is so high on the corn is because they were utilizing manure as their nutrient source, and as opposed to it being a nutrient source, they were looking at it as a dump, a nutrient dump, a way to get rid of something. So they wasn't accounting for it, as an added fertilizer benefit. It was just something they needed to get rid of, and so that added one more operation to that, which resulted in more energy being used. But our other component is no-till. Of course, we said, and I believe it's the cornerstone of soil health. Alex showed you that graph, the carbon. This is one of the big deals that adds carbon back. Here is a no-till. This is a rye. It was cereal rye, and then he planted another cover in it. You can see how thick that is versus out in western Kansas. They were harvesting their residue off here for hay to try to make cover crops work. They figured you had to either hay it or you had to graze it, and they didn't have cows, so they were haying it. You see what a detriment to the soil surface that's done. No carbon. The comparison between the two, you can see that crusting is going to occur in that first 3 inches versus the conventional till versus the no-till. And but the one downfall of the no-till is that nutrient stratification. You're going to get a lot of layering of some hotter layers of nitrogen and phosphorus with the conventional, or with the conservation tillage as opposed to the conventional tillage, because you're mixing it up. So soil quality in no-till is a function of those physical, chemical, and biological processes. You can see those different services that are being achieved. And so when we say mimic natural systems, these are the things that we're looking at. And what it does is provide, the big key here is providing more resiliency to that system. You're able to withstand, a drought system in 2 out of 5 years better than your neighbor would if they would. So how do you go about doing that? This is an example. Only 4% of this is in perennials right now. This is a computer animation. What's it providing? You can see this is just a general system. Crop production, we got really low added benefits in the others. If we increase to, it's 28%, adding that much more perennials to this system, you can see we've increased a little bit on some of these. We've increased quite a bit on our water quality, flow and regulation, and also some of the carbon sequestration just by adding that little bit of perennial. And then we have, lastly, 64% of that photo is in perennials, either trees, shrubs, brushy cover, or grass. And you can see that we're mimicking more of that native system. It doesn't necessarily have to be within the field. You could even do it around the field in your lows, seeding those back down. A lot of people tore all that out and are farming them. So in summary, these are our 4 keys, and you've heard them from Alex, and we went through them here. But what they're doing, is overall is providing that biology back to the soil that was missing, which then in turn increases that system and makes it a better system in the long run. A lot of producers that go to this more eco-type farming, are becoming more observant. They're starting to key in on a lot of the different changes that are going on, either in the soil or animal health, you know, from grazing these forages, and also even in pest, you know, infestation, the decrease in that. I'll just show you this other graph here. This is again, the PMC, we did the dye test. So it's kind of hard to see. This is an actual knife blade, which is grossly overflown. But what he did was he poured this dye in, and he was testing some different dyes to see how deep they would go. You can see our 6-inch level right there. They kind of quit right about there. But that's just kind of a graphic of how deep that soil will, or the water will infiltrate when it's in that dyed system. That was just food coloring. We tried it out. Or no, RIT. You know RIT, which dye clothes. RIT works really great, and it's about $200 cheaper, apparently, than that soil dye. It's quite a savings. So you can do this on your own farm if you like.